Welcome back. So we're picking up with a few different examples of types of locomotion of mammals. And the next one that we're going to look at is climbing. The various words that you may hear to describe mammals that climb are arboreal, it means living in trees, or scansorial, those are mammals that sort of scurry around in bushes or in trees, like squirrels. And we're going to take a quick look at squirrel being scansorial. Alrighty, so there are sort of three different modes of being arboreal or climbing around in trees. The first is associated with species that have a small body size in comparison to the things that they're climbing on. So like the squirrel. And these climbing species are pretty much like terrestrial quadrupeds, except they're moving around in trees. And they depend on having sharp claws that help hook them into the substrate. So as they're climbing like the squirrel, they can hang on a vertical surface with the help of those claws. I love to show this picture and quiz everybody on what it is. Do you know what it is? It's a koala. So you think of koala like a teddy bear, but they've got some monster claws on them, and that just helps hook them into trees where they live almost their entire lives. It keeps them nice and stable in those trees. All right, so larger body size species often show prehensility. And what prehensility means is that they can grasp things. So if you look at your hands, if you look at the hands and feet of a spider monkey here, or if you look even at the tail of some primate species, they are long and able to grasp branches so that they can be arboreal and be secure in that environment. You'll also see traction pads on the bottoms of the feet and the hands, and also on the tail, so that helps them keep a good grip. So prehensility is a characteristic of hands, feet, and sometimes tail. It's associated with not having claws, but having nails instead. So you just need to look at your own hands and feet for an example of that. And as I pointed out, it's associated with friction pads in all those places. The third mode is suspensory, and this can happen in large or small body size species, but we mostly think of it as being a characteristic of large species like a sloth. And that is associated with hanging from the underside of tree limbs and things. And these species have elongated front limbs. They have curved finger bones and curved claws that function sort of as hooks to keep them in place so that they don't have to use muscular effort to hold themselves in this position. Being suspensory is also associated with fusion of the cervical vertebrae, so that just helps keep the spine more rigid and the body more compact and rigid while it's hanging in the trees. Moving along to digging and burrowing. Whoops. I just realized we skipped over gliding and flying. So we're going to go backwards to gliding and flying. These two are grouped together even though they're somewhat different modes of locomotion. They're grouped together because species that fly and glide all have a membrane that stretches between the front and hind limbs called a patagium. So here's a flying squirrel, and you can see the patagium stretching from the wrist to the ankle in this particular animal, and then also from the wrist to the neck. So it forms almost like a parachute that allows the animal to glide from high places in trees to a tree a little farther away, and it'll land a little bit farther down, but it only comes down out of the air very slowly as it moves through the air. In flying mammals, there's also a patagium, and the difference between flying and gliding is that gliding species can only go down, and flying mammals or flying animals can go up and down. So let's look at a couple of pictures. So this is a flying lemur, and you can see the very, very large patagium that stretches from the neck through all the fingers to the hind foot, through all the toes, and to the tip of the tail. And that allows the flying lemur to be able to move large distances from tree to tree with only losing a little bit of altitude as it moves. Our flying species, the other name for this is volant. They also have a patagium, so you can see the membrane stretched here between the neck and all the digits of the front limb and then to the ankle. And some bats even have a patagium that encases the tail. So we'll look at a couple of videos. So here you can see the bats flying, and they flap their wings just like a bird would, and they have the ability to go both up and down as they're flying. Gliders, on the other hand, can only go down, even though they only lose a little bit of altitude as they travel far distances. So I'm going to play the video of the sugar glider. The first thing you're going to see is the sugar glider is in the trees. He's going to jump out, and then he's going to extend both arms, both legs, and the patagium will stretch out and form a sort of parachute. And then he'll use his tail to sort of guide his flight. That's for stability and also to enable a little bit of steering. So the last interesting tidbit about gliding in particular is that it's evolved independently in several different mammal groups. So there's a couple of different groups of rodents that glide. There are a couple of different marsupial groups that have gliders in them, and then also the flying lemur, which is a completely different order of mammals. So it's actually fairly widespread among mammals, even though it's a very, very specialized form of locomotion. Flying, on the other hand, has only evolved once, and that's been in the bats. Once in mammals, anyway, and that's in the bats. All right, let's go to our final category, which is digging and burrowing. And the technical term for this is fossorial. So we're referring to things that live almost all their lives underground, like this mole. So let's go over the characteristics first, and then we'll look at a couple of videos. Most species that are fossorial dig with their forelimbs, and they have very broad forelimbs that and long claws that break up the dirt and help push it around. One exception, though, is in the mole rats. That's a group of rodents that lives underground, and you've probably heard about naked mole rats before, but there are other species of mole rats that have fur. Here's our naked mole rat, and if you look at their feet are plantigrade, just like you would find in lots of other mammalian species. They don't dig with these feet, they dig with their teeth. So they're gnawing through the dirt to break up the dirt, and then they use their feet to push the dirt around and get it out of the way. But their mouths will actually close, so this is a mole rat with a closed mouth, but the teeth are still sticking out. So that enables them to dig through the dirt with their teeth without getting the dirt all down their digestive tract. All right, so short, broad forelimbs in the other species that dig with their feet, and the forelimbs are sort of splayed to the outside so that the animal almost is swimming through the water. It's almost like a breaststroke motion of through the water, through the dirt. The animal is pushing the dirt around it as it's moving through the dirt. They also have a lot of vibrissae through their bodies, so if they're in a very dark environment, they can't depend on their eyes to be able to see what's around them. So they have sensory hairs that occur in many places on their body. So many mammals have vibrissae around their mouths, and you can see little teeny white specks where this naked mole rat also has vibrissae there. But you can also see them down under its body. Here's some more here. They have vibrissae on their legs. They have vibrissae on their body surface. And so they use these sensory hairs to feel where the insides of their burrows are. A couple of other characteristics that we see in these species that are fossorial are small eyes. Eyes don't really do you much good when you're in a very, very dark place all the time, so those are less functional. And they often lack pinnae, so the external ear that we see in a lot of species of mammals, that unique feature that's found only in mammals, is not found in all mammals. So in fossorial species, we don't see pinnae. I'm going to play a couple of quick videos of moles burrowing. This first one, it has burrowing through, I think it's couscous, just for the purposes of filming so that you can see the motion that it takes. So here's our mole. And here it is in the couscous on X-ray, and you can see the bones, you can see the front feet pushing the substrate away, almost like it's swimming. And you can see there the very large paddle-shaped feet turned to the outside. You can also see, or not see, its eyes and its ears. Its eyes are very tiny and sometimes covered over with skin. One last video. This is a mole remover. So if you have moles in your garden, you call somebody to take the moles out of your garden. This guy traps them live and then sets them free in other settings. And so he's got a mole here that he's removed from somebody's house, and he's going to let it loose, and you'll get to see it digging a hole into the dirt and how quickly it's able to do that. So you notice it doesn't go very deep. It's just under the surface, but in a few seconds it'll be totally submerged and you won't be able to see it anymore. And there it goes.